So, hi, Amy. How are you doing?
Hi, sir. Yeah, okay, thank you. Just a little bit ill, so yeah, it's getting a bit cold in England, so yeah.
You'll get well soon. Don't worry. So, let's continue with wherever we were looking into moments, right?
Yeah.
Today, what will you like to do?
Could we cover a chapter in moments called like tilting,
Sure,
if
we should.
that's okay?
You can share the questions from your book. We'll go from there.
All right. Yeah.
Let's begin with an example, and then we'll continue with the concepts. Is that okay?
Yeah.
Okay. So, Amy, what do you know about tilting?
So let's say like, with the diagram, let's say there's tilting about the point C.
Mm-hmm.
The reaction or like the tension at D would be 0.
Yeah.
And then you just find the moments at each point, and I guess go from there. That's what I kind of did at school. I don't really understand how to explain it. But,
That's
yeah.
okay. So we can read this. So when a rigid body is on the point of tilting about a pivot, the reaction at any other support or the tension on any other wire or string is 0, right? So it is about, let us say, about a tilt at C. In that case, as you are rightly saying, the tension or reaction at D will be 0, right? So the whole force is at C itself at that point, right? So the question here is, a uniform beam AB of mass 45 kg and length 16 meters rests horizontally on the support C and D, where AC is 5 and CD is 9. When a child stands at A, the beam is on the point of tilting about C. Find the mass of the child. So we have a child here standing at A, right? So we don't know what the mass is. Let's say M is the mass. So mg will be the force with which the force will be acting at A. So now we can, at this moment, take the moments about the point C, because at this point we know that the reaction at D is 0.
Yeah.
So think like this, all the force is at C at this moment, at the time when it is about to tilt. Okay.
Yeah.
So that is what it is. So we'll, as the diagram shows here, RC is the reaction at C, and taking moments about C itself, so RC moment will be 0, correct? So center of the mass will of the rod will act at the center. Mass is 45, so 45 G Newton is acting at the center. Since the rod length is 16 meters, so half of that will be 8, correct?
Yeah.
So now we know from C to A is given to us as 5, the other side is 9 for us, up to C to D. So now taking moments at C, we can say this is like clockwise, and this is counterclockwise, this is clockwise, they should be equal, correct? So mg into 5 is equals to 3 times 45 G. And when you equate it, you get ms 27 kg. So that is how you'll find the mass of the child at A, right?
But if the if the anti-clockwise and clockwise are equal, then there will be no tilting.
No, it's just before tilting. So at just before tilting, both are still equal, right? But the important thing is, at this time, the reaction at D is 0. Therefore, when we took moments at C, so RD into 9 will not come into picture because it is 0 times 9.
All right.
That's the whole idea. So from the center, the mass of the rod itself, beam itself, will be one force, and the other one will be because of the child. So this and this will cancel. That is what it is. Is it okay?
Yeah.
Fine. Let's take some examples. More space to work here. Okay. So let's do question number 5.
Yeah.
Which is a uniform plank of mass 100 kg and length 10 meters. So let me just, let's write down 10 meters. Uniform plank, that means 100 kgx right in the center, which is at 5 meters, right?
Yeah.
So this is 5 meters.
100 G.
100, you're right. Length 10 meters, rests horizontally on two smooth supports A and B, as shown in the diagram. A man of mass 80 kg starts walking from one end of the plank A to the other. So it starts walking from A to the other. Find the distance he can walk past B before the plank starts to tip. Okay, so that means somewhere here, right? So it's walking in this direction. So 80 kg. So we'll put 80 kg. 80 kg. So when the person is walking here, it is going to tilt about B, right?
Mm-hmm.
That will be 0. Clear?
Yeah.
So I think this diagram is okay. Find the distance he can walk past B. So let this distance past B be X.
So yeah, B to 80 G is X.
Yeah, B to where the person is there. So we'll call this as P.
Yeah.
Fine. So because it is tilting here, we will calculate the moments about point B itself. And there are two forces acting. One is on the left side, which is the weight, 100 G. So we have the equation 100 G times the distance, and the distance between them is how much? 2, right? Because total is length is 5. So this is 2 units.
Yeah.
That should be equal to 80 G times X, because it is X units from B, correct? So that should give us the value of X, which will be 100 G times 2 divided by 80 G. So you can now calculate G and G cancel. 2 goes, this goes 4 times, and this is 2.5. Right?
Yeah.
So B to P is 2.5 meters. Does it make sense?
Yep. So they have to be equal because
At this point it tilts, right? So the person can go maximum 2.5 meters from B. Find the distance past B before the plank starts to tip. So 2.5 meters from B. I think that's clear.
yeah.
Okay, you get the same answer here, right? Perfect.
Mm-hmm.
Good. Now let's clear the screen and take question number 6. 6 is a non-uniform beam PQ, P2Q is a non-uniform beam of mass m kg and length 8a. So all are general terms, right?
Yeah.
And horizontally in equilibrium from two wires M and N, okay, where P to M is A and Q to N is 2A, given here in the diagram. The center of the mass of the beam is at a point O, okay. A particle of mass 3 by 4 m kg is placed on the beam at Q, and the beam is on a point of tipping about N. So we have a mass of at Q 3 by 4.
Wait, so non-uniform beam.
So a particle of mass 3 by 4 m kg is placed on the beam at Q, and the beam is on the point of tipping about N. Okay, so about N is going to tip.
3.4, 3/4 mg.
Yeah, G, correct.
Wait, and at O it's mg.
Yeah, yeah.
Okay.
Mass they are talking about. So M, wherever we have M, we'll have mg. So non-uniform B, so the with center at O. Okay. The particle is removed and replaced. Oh, first part is show that ON is 3 by 2A. Okay, so we can, so mass is m kg and it is hangs horizontally on an equilibrium plate, two wires M and M. P to M is A to A. The center of the mass of the beam is at O. The particle of this one, so center of the beam is at O. So that is the center. We don't know how far this is, which is X. And O mass is M, mg.
Yeah.
Okay. So I think the diagram is okay. Show that ON is 3 by 2n. So because it is tilting at n, we'll go to either side and check the moment. We know
So
this
because it's tilting at
yeah.
n, sorry, the tension at m is 0.
Yes.
Okay.
This tension at m is 0. Yes.
So mgx must
mgx.
equal 3/4 mg2a.
Yes. Let me change
Okay.
the color. mgx should be equal to 3 by 4 mg times 2a.
The mg's cancel.
Correct. And x is equal to 3/4 times 2a, so which is 3 over 2a.
Okay.
Yeah. Which is what we want, right? 3 over 2. Correct? So first part is
That makes sense.
Part B. The particle is removed and replaced at the midpoint of the beam, and the beam remains in equilibrium. So now this particle is removed and brought to 4a. So midpoint means 4a, correct?
Wait, what particle is removed? Oh,
That
n.
3 by 4 mg.
Oh, that particle. Yeah.
It is removed from Q. Now it is no more at Q. Okay. It is removed from Q and is brought to the center. Okay. So the particle is removed and replaced at the midpoint of the beam, and the beam remains in equilibrium. Find the magnitude of tension in the wire attached at point N. So we have to find tension of the wire at N. Okay. In terms of M. So that is what the question is. So at this point, since we want tension at N, we will take moments about M.
Oh, okay.
We'll take moments about M, and it's an equilibrium. Yes.
So does the anti-clockwise must equal the clockwise?
Yeah. So tension at N is only force which is anti-clockwise, others are clockwise. Do you see that? And it is N is how far away from this point? M? M is 2a, we have to take away from 8a, so 6a away. So we have 3n times 6a equals. You understand?
Wait, sir. So you know where you put 3/4 mg?
So 2a, 3a, sorry,
It's 3a.
3a, and this is 5a, right, in between?
But I thought the total. Oh, why are we taking the whole thing?
Because we have to take n to m, so it will be 5a. Find the magnitude of tension in the wire attached at point N in terms of M. So we'll calculate the moment about M. Is it okay?
Yes, so we have to look at M.
Yeah. So from Tn, it is 5a away because the total length is 8a, correct?
Yeah.
So Tn times 5a equals 2. Now the counterclockwise, this is acting in this direction. They will act in, these two are acting in this direction. Is it okay? So counterclockwise is 3 by 4 mg times the distance, which is, because it is in midway, 4a minus a, which is 3a.
Times 3a.
Right. And the mass, actually mg, is at O, and we found the value of x, right? X was 3 by 2a, right?
Yeah.
X was 3 by 2a, and therefore its distance is 5 and 1, 6, 6 minus 3 by 2a. 6a minus 3 by 2a.
Oh.
because 3 by 2a was the distance from O to N, right? Which we found, O to N, 3 by 2a. Is this clear to you?
Kind of.
Okay, let's go through it once again. The left side is clear to you. The tension at N makes it a counterclockwise moment about M, and that is Tn times 5a, right? Because the distance.
Yeah, that part makes sense.
Now the other moment is clockwise, which is because of the weight which we have put at the center, which is 3 by 4 mg. And since it is in the center, so it is 4 away from P, minus A means 3 away from M, correct?
Yeah.
Now point O we found was actually 3 by 2A from N, correct? We found this 3 by 2A.
Mm-hmm.
So from O to M, what is the distance?
3 over 2a plus 5 plus.
No, you can see from
5a.
No, see.
Oh.
8a minus 2a is 7a, right?
Yeah.
Let us say from here, right? 8a minus 2a is 7, correct? If I further take away a, it becomes 6a, correct? And from 6a, I take away 3 by 2a. So I get 6a minus 3 by 2.
But we want O to M.
We want O to M, yes. Can you reduce the screen so we'll see the diagram more clearly? Yeah. So oh, that diagram vanished.
Really?
Let's get back to the original. We have drawn on the original diagram, right? So that vanished.
Oh.
Oh my God. Yeah, this is the thing, right? Oh my God. So difficult to work like this. Right. Yeah, good job. You aligned it perfectly. So,
yeah.
Amy, the thing is, we want this length O to M, right?
Yeah.
So this is, you have to take away 2a and a, 3a, right? So we are left with 6, 7a, right? So 8 and 3, 5a. So from this 5a, we have to take away 3 by 2.
Yeah.
So 5a.
See, that's why I was confused.
Oh yeah, you are right.
Oh, okay. I was just confused where the other a came from.
Good job. Yeah, 5a minus 3 by 2. It makes
sense.
Okay,
so 7
now
over
you need
2.
To calculate. So 10 minus 3, 7 over 2. Yeah. So we have on the right hand side, 3 times 3, 9. So we write this as 9 over 4 mga plus 10 minus 3 is 7 over 2 mga. And here we have Tn times 5a. So I'll divide this by 5a. Is it okay?
Yeah. So when you divide that by 5a,
we can
take the a's cancel.
A's will cancel. Mg is there for sure. And then number 5. So we can take this common denominator as 4. So we'll make it 20. You understand?
Yep. So
I'll write this as 18. Sorry. I'll write this as 9 plus 7 plus 2 is 14. 7 times 2, 14, right? Over 4 times 5, 20. We'll take 20 as our denominator. Is it okay?
Yeah.
That much mg. So 9 plus 14 is 23, right?
23 over 20.
23 over
mg. Oh.
So that is what we get the tension. 23 over 20 mg.
I really understood that one. Yay.
Oh.
I'm getting it now.
Good job.
It's really clear. Yeah.
So we finally got it, right?
So yeah, it's just a little bit fiddly, but like It's understanding where the tilting happens and which part gets zero, which one, where does it like occur. But it makes sense. It's not that. It's all
Not
about the
just that,
diagram.
right? Correct.
If you get the diagram wrong, everything else will be wrong.
Perfect.
So you have to spend a lot of time on the diagram.
Perfect. So finally, if you have understood this, that's great. It was a brilliant question, Amy. So first, in question number 6, you first place that mass at Q, and with that you found the length O to N, which was 3 by 2A. And then you brought that mass back to the center. At that time, the whole system was in equilibrium. And so we calculated the moments about M, correct? So from O, the distance which we calculated was, this was 5, total is 5A. So this is 5A minus 3 by 2A.
Yeah.
And we know this one is 8 is 4 minus 1, 3A, right? Correct. So that helped us to find and there was a total mass here, which was given to us as how much? MM. Okay.
Yeah.
Correct. So that was good. So I think we can end here, and I hope you have understood what tilting is, right?
I have. Thank you so much, sir.
Perfect. So, so what did you learn about tilting today's lesson?
Yeah, so like a lot, because the main part for me was I didn't know where to, when they add a particle, I didn't know where you put it and what part becomes zero and stuff. So at the point of tilting, you have to, like, the reaction at that force, you don't use like in your calculations. So, but other forces, like about any other like part other than the one that is tilting, becomes zero. So when you add a particle, it has to be like next to or near the part that is tilting so that it can tilt. And then when you add like additional forces in that, you can't have two forces on the same side of the tilting because they will be both going the same way. So we want them going like opposing ways so we can cause that motion. Yes. And then we learned a lot about making the diagram really clear, knowing the distances from each point. And when they give you so many unknowns, like the last question we did, you can see exactly, like, even though it was a lot of A's and M's and everything, we still like got there in the end because the same principles apply.
Good.
So that was super helpful.
Yeah. So I think that makes sense. Yeah. Okay, then get well soon, and then we'll continue with our classes.
Thank you, sir. Have a good rest of your day.
All the best. Good day.
Bye, sir.
Bye.